Good day. My name is Mark Lucchetti, Associate Field Marketing Manager with Wiley Science Solutions. Welcome to today's webinar entitled Introduction to Know-It-All for Multi-Spectral Techniques. It is my pleasure today to introduce you to our speaker for this informative session, Assistant Editor Dr. Leanna Aragon of Wiley Science Solutions. Dr. Aragon helps create tools for spectroscopy, structural, and scientific standard reference data and helps create innovative software applications. She completed her PhD in clinical bioanalytical chemistry from Cleveland State University, where she developed a protocol for processing hyperspectral image data. Leanna joined Wiley in 2022. We are excited to have Dr. Aragon present us today her webinar entitled Introduction to Know-It-All for Multi-Spectral Techniques. We encourage the audience to submit questions, which will be addressed at the end of the session. With that, I'll turn the stage over to Dr. Aragon for her presentation. Take it away, Leanna.
Thank you, Mark. So what is KnowItAll? KnowItAll provides all the tools that you need for effective spectral analysis. When combined with Wiley's comprehensive spectral databases, you have an unparalleled solution for spectral analysis. You have access to the latest technologies with patented tools that you can't find in any other packages, plus expert and automated features to accelerate your workflows. KnowItAll supports multiple techniques, so whether you use one or several techniques, this is an ideal vendor-neutral solution for your lab. Even if you change instruments or add new techniques, you won't disrupt your spectral analysis workflow. It supports multiple techniques and formats, including IR, Raman, mass spec, NMR, and UV-Vis, and the software is also VPAT 508 accessible. With all the tools that you need for effective spectral analysis in a single easy-to-use interface, KnowItAll will save you time, improve your workflow, and increase your ability to reach conclusions from your data. KnowItAll integrates qualitative and quantitative tools that can fit into your current protocols. So in terms of our spectral databases, Wiley is the leader in spectral data with over 2 million spectra. That's the world's largest collection. We aim to improve analysis and identification, reduce errors, and increase productivity by providing the high level of quality data required for results you can rely on. We have broad compound coverage, and we are constantly adding spectra to our libraries to meet evolving needs. This is trusted data from a trusted source. And the bottom line about spectral analysis and KnowItAll is this is consolidated laboratory software. That means you don't have to deal with fractured software and processes. It's intuitively designed in a single interface. KnowItAll eliminates the need for multiple software packages because it's compatible with so many different chemical techniques. It's fast searching on large and accurate databases. And next I'll be giving you a demonstration of the software covering mass spec adaptive search, orthogonal search, and our new predicted IR library. So when we first open KnowItAll, I want to show you a bit about how to navigate. So on the left side, we have different toolboxes. If I click on Basics, you'll see Chem Window, which is our structure drawing application, Report It, which is our reporting tool, and so on. In the data toolbar, there are applications for data mining, such as Search It and Mine It. I'm going to start in Search It, which we'll be using for a spectral search tool. So my first demonstration has to do with mass spec adaptive search. This is going to find similar compounds in the library where a fragment group can be present or absent compared to the unknown. So I'm going to open a data set by clicking Spectrum, and I want to open this 2-hydroxybenzoic acid. So right now I want to make sure that adaptive search and reverse search are both unchecked because I want to show you the traditional way of searching without that. If I click User Select, I have the option of selecting which of the databases I have access to that I actually want to search. I'm going to look for one specific database, this Wiley Registry of Mass Spectral Data, and I'm clicking add. So anything on the bottom half of the screen, this is a list of databases that I'm actually going to be searching, and clicking search. So at the top, you see our benzoic acid in blue pointing up, and the bottom half is whichever one of these hits at the bottom I select. You can also see a structure of the selected hit. So our first hit is salicylic acid with a very good hit quality index of 97.52 out of a scale of 100. So we have a good match. We know what this is. But the power of adaptive search is when your library doesn't have a good hit. So let's just pretend like our library did not have this salicylic acid, and we were looking at these next few. So this is a traditional search, but I want to show you what it looks like if we use adaptive search. So I'm going back to search it, clicking spectrum. This time I am selecting adaptive search and searching again. So we still have salicylic acid as our top hit, but let's look at this second hit. We have a much higher HQI than we did without searching using adaptive search. But we have a column now, a new column called delta M, or the change in mass, and it says -14. What this means is that this hit is different than our unknown by a mass of 14 atomic mass units. And this replacement column gives us some ideas of what might be causing that different mass. If I click on this information button, at the top, you see our query spectrum. At the bottom, you see the uncorrected reference spectrum, the one in the database. And in the middle, you see a corrected reference. What you are seeing is that in order to get a good hit score, a lot of these peaks needed to be moved by 14 units in mass to charge ratio. So let's go back and look at these structures. Salicylic acid, we have this toluene group and a carbonyl. And in this top hit, instead of an OH group here, we have an OCH3 group. And that is a difference of 14 atomic mass units, having a CH3 replace a hydrogen. So what adaptive search does is it gives you other hits and it tells you how far they are off. So that is the power of adaptive search. So my next demonstration is going to be orthogonal search. This is when you have multiple spectra of the same sample gathered using different methods. So I'm once again going to search it. This time I'm clicking new search. And I'm going to remove all of these databases. So the two data sets that I have, one is for IR and one is for Raman. So I am going to first limit my list of databases to everything in IR, and I'm adding all of the IR databases. I'm going to do the same thing for Raman. Raman, add all. So I have a large list of databases that I'm going to be searching, and it's all of my IR and Raman databases. So clicking spectrum, and I am navigating to a different data set. So I'm using unknown D for IR, and I'm opening it, clicking spectrum again, this time unknown D for Raman, and I'm opening it. And clicking search. So right now, the IR and Raman spectra are being searched against our databases for IR and Raman. Okay, so our top two panes have these tabs, so I can select IR or Raman for either one. I don't really care for the butterfly view when using IR and Raman, so I changed the view. Okay, that's better. Because this was a multi-technique search, there is a plot at the bottom for our HQIs, our hit quality indices. So this x-axis is our Raman spectral HQI, y-axis is IR spectral HQI. And whichever one of these points I click on, we see the structure change and we see the spectrum overlaid over our unknown change. So this is our best hit with high HQI in both IR and Raman. But let's just explore some of these other points. So if we didn't have the good hit in our database, we might be looking at some of these others. Okay, so these 2 points are interesting. The Raman spectral HQI for this point and this point are very similar. These 2 compounds would be difficult to separate in Raman, but they have different scores in IR. So using the orthogonal search, we're able to differentiate these 2 compounds. Likewise, we have a pair here with similar scores along the y-axis for IR, but different scores along the x-axis for Raman. So let me search once again. This time I'm going to search using all compounds instead of user-selected database. And you're seeing a pretty similar plot. You're still seeing point up in the top right with high HQI in terms of both Raman and mass spec. But if we didn't have these and we just start clicking around, looking at the other compounds, you might see some structural similarities between them. Oh, here's something interesting. We have a pair of stereoisomers. So you can see that they would be difficult to distinguish in IR because they have similar IR scores, but easier to differentiate using Raman. So these are R and S isomers of 2-amino-octane. So yeah, these do have lower HQIs, but the reason I think they're important to point out is that we would want to look through the scatter plot if we don't have a good match, if we don't have this point in the top right corner. So these 2 isomers are linked by structure, name, INCHI key, CAS registry number, synonym, other information in our databases. Okay, my last demo is going to be our predicted IR library. So this involves a database of predicted IR spectra. So Wiley has the world's largest collection of high-quality IR spectra, including Sattler and Hummel databases. But sample collection is challenging, time-consuming, and costly. And Wiley's library of predicted infrared spectra is an attempt to increase the catalog coverage of Wiley's IR chemical space. This does not mean to increase the chemical space, but to increase the amount of coverage within the bounds of our current library's chemical space. It's helpful in illuminating the composition of an unknown spectrum or accurately predicting compound spectrum for the associated structure and functional groups. But because of the predicted nature of the spectra, the results aren't perfect, but I'd like to demonstrate what they can do. Once again, I'm going back to search it. I'm going to open a new spectrum. And it is this particular sample that I'm interested in. So I'm going to select used computed spectra under all compounds because that's going to include the predicted IR database. And I'm clicking search. And for our top result with an HQI of 91.51, we have this structure that's shown on the top right. I actually have an image of the structure of our query spectrum. And if you look closely, you can see that these are the same compound. They're drawn in different conformations, but they are the same. So our predicted IR library did have a hit for this particular compound. This concludes our demonstration on the KnowItAll multi-technique tools. If you have any questions, please visit the Wiley Science Solutions website at sciencesolutions.wiley.com. This is the end of the presentation. We will now open up the floor for some questions.
That was an excellent webinar, Liana. We reached the end of our presentation today. Thank you, Dr. Aragon, for your time and expertise to present us your talk on the introduction to KnowItAll for multispectral techniques. Joining us today for the Q&A will be Dr. Michelle D'Souza, also of Wiley Science Solutions. We'd now like to open up the session to some questions from our attendees, which, if you can type, please type in using the questions toolbar. That would be great. Okay, here's one. Let's see, for this demo, we saw the comparisons with Raman and FTIR. Can other spectra be searched as well, like MS and NMR?
The answer is yes. And you can even search IR, Raman, NMR, and MS if you have all the databases. You can search 4 techniques together. But you see the display plot, scattering plot would be 2 techniques at a time.
Thank you for that, Michelle.
Mm-hmm.
How about this one? If I am building a database, can we put multiple runs of a sample into the same record?
Yes, we can. Yes, we can. It's database building and holding a different type of spectra in the same record, as well as different runs of the same type of spectra in the same record is one strong capability of KnowItAll.
Great, thank you, Michelle. So based on your last response, how are different technique records linked in multiple analytical technique research or search, excuse me?
Yeah, they linked first by structure, so uniqueness of structure links two different records from different databases together. And also, if structure is not available, they would link by inchi keys, cache number, or synonyms. KnowItAll has an intelligent way to link records together, so you don't have to build them, pre-build them at the same compound properties.
Thank you, Michelle. Here's a good question. Can I add our in-house database into the search?
Yes, you can. In-house database can participate all the searches as well as mixture analysis, so to help user to identify compound.
Thank you. All right. How about this one? How is it possible to do deconvolution in this application, for instance, for FTIR and Raman?
Deconvolution, I think you meant by mixture analysis, so to separate different components. It is, we have algorithm to find a different component for a mixture compound and then put together composite spectrum, which is a curve fitting, not necessarily a concentration ratio, but curve fitting, and then to match the unknown spectrum. Maybe not in the sense of deconvolution, very complex mathematics sense, but it works.
Thank you, Michelle. How about this one? Are there spectral range restrictions per analytical technique?
No. For example, IR can go anywhere from 800 to 3000 or 400 to 4000 in the same database.
Excellent.
Mm-hmm.
Let's try this one. Does the software adapt algorithms depending on the type of spectra? For example, when using NIR and ATR and ATI or IR spectra.
For IR and let's focus on IR ATR. So we do have ATR correction and a reverse ATR correction algorithm. So if you have ATR spectrum and you don't have the ATR spectrum in reference data for that particular compound, but you have IR spectrum, so we perform automatically ATR correction to match the IR spectrum. And if you have IR spectrum and don't have necessarily have IR reference spectrum, you have IR unknown, then you can match the ATR spectrum. That's the automatic reverse correction. But we don't have a correction between near IR and ATR. So it depends on technique.
Great, thank you, Michelle, again. Is there an LC-MS library?
Yes, in the form of a NIST library for now, and we're working on incorporating it into a KnowItAll library.
Thank you. How about this one? Does the predicted spectra give you possible hits based on the predicted spectral library? Or does it generate a possible hit by simulating a predicted spectra based on your query spectrum?
No, it doesn't. For the second case is no, it doesn't not simulate a predicted spectrum based on your query. No, we have a predicted spectrum generated, and then you can use your unknown spectrum to match experimental data as well as predicted spectra at the same time. Whichever one comes as a high HQI hit is on top. So there's no difference for us.
Excellent, thank you, Michelle. Let's try this one. Is there a feature that allows us to see the chemical bonds by peaks of the spectrum on KnowItAll?
Yeah, there's a feature. Yes, it's called analyzed application. So you can import a spectrum and click a band, for example, IR band, and find out what kind of functional group could generate that band. So it's a little application. It's very useful for chemical classification.
Great explanation. Thank you again, Michelle. How about this one? Do you have any batch functions?
Yes, you can do batch in KnowItAll, or you can run automated. You can execute KnowItAll entire searches in the batch mode. Means you don't see KnowItAll. You can use the new tool released with 2024.2 to run completely a batch folder of spectrum in batch mode and generate a report.
Thank you, Michelle. Let's see if we have any others here. Here's a good question. What vendor file formats are supported within the software?
Yeah, we have about 130 different kind of vendor formats supported. So most instrument format and the generic formats are supported. And we're working on increasing the support all the time.
Thank you, Michelle. How about this one? Is it possible to categorize bending, stretching, and so on in
Yeah,
FTIR
you can.
spectra for a specific group?
Yes, you can. You can do that pretty easily. You can create your own database, databases, knowledge base, we call it, of all the band, and then you can specify what kind of, you know, formation your band is, and you can corresponding to a region, so you can use it.
And then to piggyback on top of that one, Michelle, given the popularity of this subject, is it AI supported at all?
Um, um, depends on what you say. We have predicted spectra actually generated. You can say it's AI. So AI supported. If you are talking about the software itself, it doesn't have much AI, but it's try to be intelligent. There are many little features that's function as very intelligent. But in terms of you're talking about AI software, we haven't reached that stage yet to figure out to be in people's mind to know what to answer.
Thank you, Michelle.
Mhm.
We may have time for maybe one or two more here. Let's see. Is it possible to do an IR spectral HQI with your own database created in KnowItAll?
Yes, you can do that. Mark, there's some questions on top. Maybe we'll answer. I try to flag to you.
Yes, some of those, Michelle, looks like weren't they were sort of statements as opposed to questions, but I guess one of them could be is it possible to see, is there a visible difference with Raman spectrum and IR spectrum for two spectrum
Yeah.
with the same chemical element?
Yes, of course. IR is focused on the band, the covalent band movements. Raman, so IR covalent band movements would generate the actually signified as functional group, so-called chemical functional group. So IR is a response safe to that, but a Raman is really sensitive to backbone. So you have a long chain, small chain. It's very sensitive to that. So a huge difference. But sometimes you see in the same position, a peak may show and peak may be weak. There's some correspondence between peaks. It was very interesting. And KnowItAll allows you to split your result to look at IR and Raman together. So you can see for the same compound, how does IR look, how Raman looks.
Thank you. I think we could potentially fit at least one more in. How about this last one, Michelle? Does the system have a database for inorganic compounds as well?
We do have IR databases for inorganic compound as well as Raman. Very limited collection, but we have some.
Maybe one more real quick one, but I think you might have touched on this earlier, Michelle. Is the software compliant with, is it 24 CFR or 21 CFR compliant?
We support 21 CFR compliance. Okay, our software hasn't gone through rigorous CFR compliant development, but we support it. So it's a research software in research environment, but for the documentation purpose and everything, for example, if you change your spectrum, we do know it's changed. So we support compliance. We report your result with the timestamp and basic information. So we supporting. I would say we support CFR compliance.
Very good. Well, I think we've reached the end of our time today for questions. I'd like to thank our assistant editor, Dr. Leanna Aragon of Wiley Science Solutions, as well as Dr. Michelle D'Souza, for taking the time to present us the talk on Introduction to KnowItAll for Multi-Spectral Techniques. Any questions that were not addressed will be answered by email if able. This presentation will eventually be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Thank you very much for attending and enjoy the rest of your day.